write down in polar form the cube root of negative I. Hence, or otherwise, solve the next equation. So let's consider w cubed is negative I. Then w is cube root of negative I, so we need to find the values of w. And how to do that? It's quite typical question when there is some complex number to the power 1 is equal to something, and you need this complex number. It's the same as to find root of degree of n of a complex number. And you should just apply a formula, and you need just apply this formula correctly. How it works? The first step is that we need to rewrite this complex number in the Euler's, or it's also called the exponential form. We need modulus and argument. So we consider this complex number, which is given as x plus iy. We consider it on the organed diagram, and we need modulus. Modulus is what is just distance from origin, and argument. Argument is angle. 0 is here in anti-clockwise positive. There are positive angles. In clockwise there are negative angles. And where is negative I? Negative y is here, and you can see that distance from origin is just 1, and angle is 3 pi over 2 as positive, or just negative 90 degrees, or negative pi over 2. So w cubed becomes 1 e to the power, let it be negative I pi over 2. Notice that this value cannot be negative. If you meet, for example, negative 1, it's what? It's value here, it's on the real axis, and it's what? Its modulus is 1, and argument is pi, I pi. So negative 1 is 1 e to the power I pi. If you need, for example, w cubed is negative 1, you cannot do something with negative 1. You should consider it like this: r e to the power I theta, where I is positive. So w k solutions are cubed root of 1, cubed because we consider w cubed in general, it's root of degree of n, and e to the power I theta k, where theta k is our argument. It's what? It's negative pi over 2 divided by n, it's 3, plus 2 pi k, or 360k if it's in degrees, divided by n, so divided by 3. Let's simplify it. It's negative pi over 6 plus 2 pi over 3, but let's do common denominator to be easier to add, so it's 4 pi k over 6. And just we consider 0, w0, w1, and k is 0, 1, 2. If you consider k to be 3, you get this solution, but rotated by 360 or by 2 pi. It's just one complete revolution, so it will be absolutely the same complex number. So there are 3 unique solutions. Since if in general, if it's w to the power of n, there are n unique solutions. Definitely you may consider 1, 2, 3, but it will be this to but rotated by 360, and it may be required arguments to be from 0 to 2 pi, from 0 to 360, and you may get this to be, for example, 390. But you remember that you can add or subtract any number of 360 or 2 pi, so it's the same as 30 or something like that. It's because complex number is what cosine plus I sine, and sine cosine have a period of 2 pi or 360. But I use such technique, so I consider 0, 1, 2. You may use notation w1, w2, w3, but I use w0, w1, w2, because I use k to be 0, 1, 2. So w0 becomes what? It's 1, and e to the power I theta 0 is just negative I pi over 6, and we need in polar form. Polar form is R cosine theta plus, it's also called modulus argument form I sine, or just R c theta, but we need finally to be in this form, so it's useful to use this directly. So it becomes e to the power of 1 and multiplied by what? Cosine, or we can ignore 1, so it's cosine of what? Of negative pi over 6 plus I sine of negative pi over 6. And it is equal to cosine is even function. Cosine of negative pi over 6 is the same as cosine of pi over 6. Pi over 6 it's what? It's 30, so it's root 3 over 2. And sine is odd function, so it's sine of negative angle is negative sine of same but positive angle, so it's minus I sine of pi over 6, it's a half. But we will need this for the next part of a question, but if we consider this question only in polar form, so you may write 1 cis of negative pi over 6, or just 1 times this, and that's all. And then for the next part of a question you may continue. Okay, W1 becomes what? 1 e to the power of what? When k is 1, it's what? 3 pi over 6, or e to the power of I pi over 2. And it's 1 cis pi over 2, and it's that's all for the first part of a question, but I will continue because we will need it. It becomes 1 cosine of pi over 2 plus I sine of pi over 2, or it's this is the same as this. So you may answer for the first question like this: 1 times cosine plus I sine. It's also polar modulus argument form, and it's quite clear that it becomes what? It's 0, 1, so it's just I. And W2, it's 1 e to the power of what? 8 minus 1, 7. I 7 pi over 6, and it becomes 1 c 7 pi over 6, or it's 1 cosine 7 pi over 6, but to calculate it we know that we can add or subtract any number of 2 pi, but it's not suitable here. But we can see that 7 it's 6 plus 1, so it looks like pi plus pi over 6 plus I sine also pi plus pi over 6, and it becomes what? Cosine of pi plus something. It's cosine of pi over 6 and negative, because it's the third quadrant, answer must be negative, since it's pi or even number of pi over 2 plus minus e cubed. It remains the same function, cosine. If it would be pi over 2 multiplied by n, where n is odd, sine becomes cosine, cosine becomes sine, and it becomes cosine or sine of just this small angle, and it doesn't matter plus or minus is here, and you just should put sine plus or minus in front due to quadrant of the original angle and the original function. So cosine pi plus pi over 6 is the third quadrant, so cosine is negative, so answer must be negative. And pi it's even number of pi over 2, or if we consider angle somewhere here and plus or minus acute, we don't change function. If it's here or here, we change function. If we consider if it's multiple of pi over 2 plus minus acute, you change sine for cosine, cosine for sine. So it's negative cosine pi over 6 plus I, and sine pi plus, it's also here, this is quadrant, sine is also negative, and pi, so we don't change, so it remains sine of pi over 6 and with minus sine pi over 6, and it's again, it's what, it's 30, so minus root 3 over 2 minus a half. And notice that such solutions, such roots are equally spaced on the organ diagram. There is the same angle between two consecutive roots or solutions. Let's check. So let's check. The first solution is what? Negative 3 over 2 minus, and the first, you can see plus, and the same y coordinate, and it's I is here, minus and plus minus, and definitely it's the same. It's negative root 3 over 2 minus a half I, it's root 3 over 2 plus a half I, and it's just I, and hence there are 120 degrees angles between two consecutive solutions. You may check. And you may notice if you add them all up, you get 0. So let's continue. We need solve. We need solve. What? 1 minus I times z cubed is negative I, hence 1 minus I multiplied by z will be equal to our solutions w 0, 1 and 2. So we can write that I minus I z is equal to root 3 over 2 root 3 over 2 minus I times a half. It's the first possible solution. The next possible solution, it's what? It's just I. And the third possible solution, it's what? Root 3, negative root 3 over 2, and also minus I a half. But finally we need just give our answers in the form what? Usual form a plus ib, so we need just rearrange a bit, and hence z1 becomes root 3 minus I over 2 and divided by 1 minus I, and we need to get rid of I in the denominator, and as usual we just what? Multiply by complex conjugate to get what? 1 squared minus I squared, it's what? 1 minus negative 1, 2 over times 2, 4, and what? Root 3 minus I plus root 3I, and minus I squared, so plus 1. So finally it becomes what? Root 3 plus 1 plus root 3 minus 1i and over 4. Let's check. Okay, the second, it's I over 1 minus I, multiply again by 1 plus I to get what, 2, and what, I minus 1, or negative a half plus I times a half. And that 3 is, let's multiply every term by minus to get root 3 plus 1 plus I over 2 and I minus 1. And multiply by I plus 1, I plus 1 to get, it's what, it's negative 1 minus 1, it's negative 4 in the denominator, and it's what, root 3i plus I squared plus root 3 plus I, and it becomes what, root 3 minus 1 over negative 4 plus root 3 plus 1 over negative 4i. And that's all for this question.